Thank you for joining the Microsoft Ignite session. We're thrilled to be presenting new technologies for the modern hybrid workforce. My name is Rami Husseini. I'm Director of Product Management at Qualcomm Technologies, and I'm excited to be joined by Russell Humphreys.
Hello there, my name is Russell Humphreys. I'm the VP of Product Management for Sophos. I am a 6-foot tall white male and I have quite a lot of grey hair. Let me pass you over to Stephen McKay, who's on my team. Stephen.
Thanks, Russ. Yep, Stephen McKay here, Director of Product Management at Sophos. I'm also a tall gentleman wearing white gent wearing a blue polo. Good to see you all. I'll hand over to Derek from Qualcomm.
Hello, everyone. My name is Derek Smith, and I am a field applications engineer with Qualcomm. And really, that is I'll be your technical SME for this Snapdragon compute platform here. So, hand it off to my counterpart here, Craig Rush.
Good afternoon, good evening, good morning, depending on where you're at. Craig Rush, field application engineer with Qualcomm. I'm 5'8", not nearly as much hair as Russell has, and based here in the US. Pleasure to meet you. Turn it back to Rami.
Thanks, Russell. As we move on to the next slide, we'll see that it's quite a unique time in this corporate world. After spending about the last 18 months working from home on video conference calls, it's great to see that corporate doors are reopening and employees are starting to return to work. This return to work structure is actually transforming into a more of a work from anywhere model. Employees will likely start their days off at the house, catching up on email in the mornings, then drive into the office to meet with and collaborate with coworkers and employees in person, whether it be to brainstorm or work on different projects. Then after the meetings are over, then early afternoon they'll have the flexibility to either go work remotely from a coffee shop or go to a customer site. So as you can see, the model will be kind of more of a work from anywhere, and this flexibility is fantastic for employees as they'll be able to maximize their productivity and make more efficient use of their time. As we move on to the next slide, you'll see that devices, Windows devices for this modern workforce need to have new capabilities. Employees who are in this work from anywhere environment need devices that have all-day battery life, persistent connectivity, and instant on, so that they have a device that lasts all day and they have access to their cloud resources, whether it be to collaborate through cloud storage or to access remote desktop capabilities. If you think about these new features, they really mirror your mobile phone, and the Windows on Snapdragon architecture was built to provide this mobility for the end user. Similarly, this Windows on Snapdragon architecture was designed for IT to manage and secure a mobile device. So we've now brought this technology to Windows PCs. We have cloud connectivity for devices to be patched in real time instantaneously. Imagine from an IT perspective, the ability to patch and update security patches instantaneously to your entire global fleet of devices. Additionally, from the mobile phone space, we've brought in zero trust into the Windows architecture. We have things like identity, location management through GPS, network risk scores, as well as device attestation, so that your remote workers accessing corporate resources, you have additional capabilities to ensure that devices are in a good health, good location, and accessing strong networks. We also have an AI engine, a neural processing unit, to support next-gen AV with their AI type of technology, so you have faster threat detection. Moving on to the next slide, what you'll see is the Windows on Snapdragon architecture, as you piece this together, delivers the requirements to be part of the Microsoft Secure Core PC. And so straight out of the box, we are definitely one of the most secure devices out of the box by being classified as a secure core PC. Moving on to the next slide, what you'll see is we take this to the next level by bringing in mobile security features. If you think traditionally, security AV products were traditionally more on-prem, on the client, but with next-gen AV products like the ones by Sophos, they're more cloud-focused. You have cloud consoles that bring unique capabilities to managing and securing endpoints. With Windows on Snapdragon and 5G connectivity, you're able to now have your entire corporate fleet of devices connected to this cloud resource, and that way you get to manage your devices at a corporate fleet level to make sure that you can discover and remediate threats instantaneously. There you go.
Very good. Thank you. Thank you very much for that. Now, as part of an overall security solution, I mean, firstly, we're very, very happy to be able to provide our Intercept X endpoint protection suite on the Qualcomm Snapdragon chipset. And clearly, we want to make the most of all of the capabilities built into the hardware. At the end of the day, though, that mobile force doesn't just work on hardware as a laptop, no matter how cool that laptop may be. The reality is that individuals work on cloud-based technologies like Microsoft 365. They may be on one side or another of a corporate firewall. They'll probably have at least one, these days quite often more than one, mobile device. The punchline here is to get a full view of what your employees' security stance is, and to protect your employees in their day-to-day work, wherever they may be, you need an adaptive ecosystem that takes the very best quality signal from a number of different sensors across a broad range portfolio, if you will, of hardware, software, services, be they actual or virtual, and put them together into a single holistic view that professional threat hunters and indeed IT administrators can get the most out of. But for today, we're here to talk about Qualcomm and Microsoft. So I'm going to give you a quick demo. It's a video recorded demo. Here you can see it's on a HP Elite with the Snapdragon chipset. And we're going to do, like all good security demonstrations should, where we take a leaf out of the cookery book, and frankly, we do the before and the after, don't we? So punchline here, here's a Snapdragon device running Windows. Here we have a user. I'll be the guilty one in this case. I'll be the one who falls for the fish. We have an unimaginatively titled document, Lorium Ipsum, and in it, we have a user who's doing some editing. I believe I'm fully protected because I'm relying on my backup or my shadow copy or whatever other technology I think is protecting me. The reality is, of course, although they're fit for purpose for backups, they're not necessarily a strong protection against modern threat adversaries who, frankly, are motivated by money and have been for quite a while. So how does a threat adversary get in? Well, there's a number of ways: identity theft, human engineering, basically convincing people to make a mistake. So that's what we'll do here. Let's pretend it's me who's been phished. Something pretending it's an Experian credit report alert. To its credit, our friends at Microsoft are giving me plenty of warnings that what I'm doing is extraordinarily dangerous. There was the little, this has got macros in it icon. If I knew such things, it warned me that it was going into protected mode. It warned me not to enable the macros, but nevertheless, I resiliently clicked on all the buttons that allowed me to get through. And inevitably, of course, what happens at this point is, unfortunately, my documents get encrypted by the bad guy. So if I open my documents, sadly, they're now full of very high entropy encrypted code. And in this scenario, if I can't get hold of the backups, if the bad guys haven't deleted all the shadow copies, maybe hit my backup server, I'm in trouble. So let's roll the clock back. That's the before. Let's roll the clock back. Let's look at this Snapdragon device, and let's look at that Snapdragon device protected by Intercept XDR. Now, at Sophos, we're a great believer in defense in depth. We have all sorts of technologies on both the endpoint and in our cloud architecture. We have a number of deep learning neural networks. We have defense in depth through IPS on the endpoint, through AMPC, which is an awesome extension interface for us, through network protections, through a very broad list of exploit protections, the industry's best. But what we're going to demonstrate here, which you saw at the end, was a series of technologies we call CryptoGuard. CryptoGuard is a heuristic behavioral set of technologies, and it will make the most out of that performance of the Snapdragon chipset. The reason performance is important and the heuristic side is important, you can't guarantee how the bad guy's going to get in. This attack reran, and you saw the documents didn't change in any way, shape, or form. We have a detection here, however, and this detection is showing that the behavior that attempted to do the encryption was caught in PowerShell. So again, this is where smart use of technology on an agent, as well as combined with the cloud, but in this case on an agent, can look at the behaviors of frankly any application, whether it be a trusted application being misused, a lol bin, like in this case, however it may attempt to encrypt, to ransom your documents. The benefit of a behavioral approach is that we can thwart it. So that was a real quick demonstration of the technologies that we've ported over with working with our partners at Qualcomm onto the new hardware stack. It's a broad defense in depth approach. I've only just shown very briefly one set of capabilities. And I think at that point, we've kind of run through the content in the deck, which is good because it's left us a good 15 minutes for Q&A. So what I'll do at this point is I'm actually going to go back to the sort of starting screen, which has our pictures on, and then open up the Q&A section so we can perhaps answer some questions on either the hardware, the software, the approaches we've taken, and anything of interest. We'll give that a few seconds to see if there's anything here. Well, I'll throw one then. Rami, I'll throw one at yourself. How are you finding with the new Snapdragon chipset? How are you finding, we talked an awful lot about its performance. We've talked about its connectivity. Tell us a little bit of something about what it's been doing for battery life and that sort of experience, because if you're constantly on the move, right, naturally the amount of time I can be away from a plug socket is kind of important to me. Maybe you could give us a few minutes talking about that.
Yeah, definitely. Thanks, Russell. That is one of the unique value props of Windows on Snapdragon devices is the sustained performance. And actually, the way we look at it is more performance per watt. So the way the architecture is, it has multiple cores. So you have a set of performance cores to handle your heavy tasks, and then you have a set of more efficient cores that kind of handle your more minimal tasks. And what that offers you is devices that bring multi-day battery life, where I've personally gone on trips where I brought my Windows on Snapdragon device. I think it was on a 3-day trip and didn't even need a charger. And so one of the it's just pretty fantastic. It's really a serious game changer to have a device that doesn't really require a charge very often. And then even more than that, we run some benchmarks using common video telephony video conferencing apps like Zoom or Teams, and you're getting about, I think if I remember correctly, over like 15 hours of video conference calls before you consume your entire battery. Which again, this day and age we're all on video conferencing, so definitely having a minimal hit to your 1 hour call is really fantastic. So it's definitely a game changer. And moreover, we're actually getting similar feedback as we've deployed these devices with several Fortune enterprises that the battery life is one of their favorite capabilities of the platform.
So with all that battery life and connectivity, I can no longer hide in the BA lounge or hide on an aeroplane anymore. I'm always on. So I suppose it's a good thing. I thank you for that, man.
Yes, always productive.
Yeah, absolutely. It's a good thing. and always protected as well. I love the concept of the constant connection. One of the benefits of blending that mobile phone use case with a laptop case is location is an important part of an overall security story. I mean, an often overused, frankly, security story is the impossible traveler one. You know, how can Russell have logged in let's say, New York, and then 1 hour later he's suddenly in London, right? And that doesn't seem terribly likely. But above and beyond that, locality, especially if we can tie, if you've got a security ecosystem that has sensors on a mobile phone and in your Snapdragon enabled device, both can send you location information. So now is the phone adjacent to the laptop? That's actually quite an interesting scenario. You can get interesting data out of having those sensors in both places. And by having that kind of always on connectivity and having a number of different modes to be able to get that through the hardware that you've brought to the market, I think opens the door some other interesting user behavior and analytics, and some of the threats that are exposed through location and attestation. Is it really Russ and his mobile device and his Qualcomm device in the same place?
Yeah. Hey, Russ, I recall in your presentation you talked about AI and deep networks and how Sophos is leveraging that. Could you add a little bit more detail? I'm definitely excited about those capabilities.
Thank you. Yeah, well, look, at the end of the day, machine learning is really good at patterns. It's really good at patterns. And we're leveraging machine learning, not just for the patterns in code. I think that's kind of table stakes these days. I mean, not all machine learning is equal. Our team came from DARPA, so they've kind of been around the security block. But that said, there's more than just leveraging machine learning to look at executables. You can actually leverage machine learning to look at non-executables, including, interestingly enough, those scripts that I mentioned and did a quick demo of earlier. Now, machine learning algorithms can run at the speed of compute, and they can look at patterns in scripts that may indicate, well, it's a likely malicious. You may not want to be able to necessarily convict or block a script, but you may want to highlight this script as, hey, Stephen, who perhaps being a security operator for us, here's an interesting script. Maybe you want to have a look at it. And what are some of the tells? Good one is in base 64, right? It could be legitimate. It might not be. So again, we're leveraging machine learning, up-leveling it just from the fairly well-known PE file. That's just a portable executable posh term for a program, if you will. But we're also using them in a number of different areas, including scripts, and we've got the technology now to be using them in URLs as well. And of course, we can also use them to look at the more common document formats, the ones leveraged by our friends at Microsoft, the PDF files and a few others as well. So we're definitely using it as a false multiplier. We're using it as a way not just to detect from a protection perspective, but when we think about EDR now in the industry, a new acronym XDR, those machine learning models, that artificial intelligence, that data science realm can actually really improve the signal to noise ratio, so that the people who have to do this threat hunting are actually best using their time on the highest quality signal, so that they're not wasting their time on just day-to-day, shadow IT or installation scripts or whatnot. So I think that's a pretty good use of machine learning. But that is a good question. Thank you.
That's exciting. Yeah, thanks.
Let's see if we have other questions at the moment.
Yeah, I think one of the questions definitely on folks' mind is looking at the technology, not only the security stack that we talked about, but also now the architecture. So how does that differ? We're used to an x86 world, and now with this new ARM architecture, how does the security differ in between those platforms, guys?
That's a really good question. And Stephen, I'm going to pass that over to you. I mean, not all architectures are always the same, of course. And ARM does have a lot of benefits. and a slightly different profile. So, Stephen, why don't you take that one for us for a couple of minutes?
Yeah, thanks, Russ. And it's a great question. So, as you saw in the demo, an awful lot of what Sophos offers in its protection is based on the operating system. So, being able to run Windows on ARM devices, was really the gateway to allow us to deploy Sophos InceptX and offer things like CryptoGuard, the machine learning that Russ has talked to, leveraging AMSI, which is obviously great technology provided by Microsoft in Windows to allow us to get access to obfuscated code. But when we started talking with people like Rami at Qualcomm, what was interesting about the architecture on ARM was how we could offload some of the work that's done in features like CryptoGuard. So looking at, for example, the DSP within the Qualcomm chip. So computation offloading. So within CryptoGuard, we do histogram calculations, and in an Intel world, in x86, that's done in the CPU. And we're having conversations about how we can move that to the Hexagon DSP and look at other mitigations that are specific to the actual ARM architecture. So, in summary, the answer is generally we benefit from the same protections we have today. So largely it's not different. But as we work together, there are definite benefits from how we can improve the computations that we do to offer that protection using the ARM architectures. Great question. Another question's come in, so I'll read it out here for everyone. Can we talk more about zero trust? Really wanting to understand, the metrics you can get. So I think there's a slide on zero trust, and we, a bit about 5G, etc. So Rami, I don't know if you want to start, and then maybe hand over to Russ. So over to you, Rami.
Definitely, yeah, for sure. So this kind of background is, obviously we've brought in a lot of our technology that we've built over the years from mobile phones into the Windows PC space. And so obviously in the phone realm, in the phone domain, mobility was key, right? And how do you protect mobile devices? And so zero trust has always been a key part of our security architecture on the mobile side, and we brought that into the Windows space. So for specifics, one of the things that we can do is, if you look at kind of some zero trust pillars, we look at it as having identity. So both from biometrics to being able to do that securely. So essentially passing in either facial ID or security through different sensors that allow it to be provided to the cloud in a secure fashion, as well as location. So on Windows on Snapdragon platforms, we bring in GPS, which allows you to have precise location to do some of the things that Russell was mentioning, and to determine that, hey, this location is in an obscure place, and be able to manage that, as well as network risk scores. So we have software-based ML sensors on the platform that can detect if a public Wi-Fi network is malicious, if it's rogue, and provide risk scores on whether or not to attach a device to it. And then also the device can send out device attestation that can notify the cloud if the device has secure boot enabled, as well as other features. And that way, holistically, looking at each of those pillars, risk scores and features, you can then make decisions on whether or not to allow the device to access corporate resources.
Yeah, if I may pile on that, I think that's awesome, Rami, and I think that hardware allows us a root of trust, if you will, to empower some further scenarios through software. Zero trust at the end of the day, I did mention I had grey hair. It's kind of, well, it's like claims-based access control, but kind of a bit more modern. I mean, at the end of the day, you're making a series of claims to either allow or not allow an individual have access to a resource, be cloud-based, be it on the corporate network, wherever it may be. And the type of hardware enforcement that these guys have built is critically important for not just the hardware, but the software that runs on it too, because any software has to be able to go back to a, well, TPM2.0 in this case, which provides a very secure root of trust. But the software also allows you to be very flexible. Different organizations may want, for example, to be able to have their own cookbook, if you will, of the claims they want to be able to make, and therefore test or attest that a device or a person or a user is whom or what they say. And this is where the combination of a very flexible XDR type solution can actually augment those type of claims, because frankly, it should be able to expose all sorts of attributes that an administrator could make rules on using, well, a well-known query language. We've built into our platform OS Query, for example. That uses a SQL-like language that allows you to get access to all sorts of attributes. So one of the benefits you could say is, I know this Snapdragon device, it's making claims of location. I know they've got a solid root of trust in the TPM2.0. I'd also kind of like to know what version number of software have they got? Have they rebooted from the last patch? Is their primary browser Edge? Right. These are the types of questions you could put together to look at a more sort of flexible and holistic approach to at the end of the day, do you or do you not trust the device, the user, and their environment they're in before you open the keys and let them into your corporate assets? It's a great combination there.
Thank you both. Yep, good answers. There's another question here. Can we talk about the difference between ARM and Snapdragon? So, Rami, one for you, please. Hand over to you, Rami.
Definitely happy to answer that. So, if you look at ARM, ARM has a couple models where they provide the instruction set, and then they also provide, a CPU design. And what Snapdragon does is it leverages that and then adds in extra blocks, engine blocks. So in addition to the CPU, we have the Adreno GPU, we have a camera image signal processor, we have an AI neural processing engine, and those are some of the areas that Stephen was actually referring to as far as being able to offload different types of workloads. And so you can think of it as ARM provides the instruction set that Snapdragon builds on top of, and then adds in all those extra engines to become a system on chip that allows you to kind of offload workloads. That helps describe the difference.
That's very good. I think there's a question here, and I think Craig, you answered it, but perhaps you, in the last minute or so we have left, you might want to add your verbal override to that, because it's a great question, I must admit. The question being, are PCs on cellular connectivity, or how are PCs on cellular connectivity safer than your more general Wi-Fi? Did you want to just add a little context to that in our last minute or so, Craig?
Yeah, really, from a contextual standpoint, think of it as utilizing your cell phone, making a normal voice call. You're utilizing the same network, same topology, same security methods, utilizing that network and your data transmission as you would that call. It's going to encrypt all of the data. It's going to verify your authentication and ensure that your session is protected all the way through and through. On the Wi-Fi network, on the other hand, really depends on how it's configured, how it's set up, and what they were doing that day when it was configured.
I'm going to presume I do not know, so I'll kind of wrap this up as a question. Man in the middle is probably harder on 5G than Wi-Fi, I presume, as an attack. I mean, the hardware requirement is probably a tad higher, right?
Yes.
Very good. All right, well, I think we're probably running up to time now. We have, according to my watch, maybe a minute and a half left. Do we have any other questions for us in the last minute or minute and a half? Quick question, is the neural processing engine happening on the device or in the cloud? Rami, that sounds like you're closing us out there.
Yeah, for sure. Good question. Yeah, so the neural processing engine is a hardware block on the edge. It's part of the Snapdragon system on chip. So you can think of it as Similar to having a CPU and a GPU right next to it, you have an NPU block right on the edge. We use that to, you've probably seen on Microsoft Teams that there was features around eye gaze protection, just to show you the performance per watt. On a traditional PC that consumed about 15 watts, whereas on the NPU is 0.3 watts. So you're starting to see how much more efficient an NPU is to calculate AI and based math versus a traditional CPU GPU on the edge.
And with that, we are at time. Thank you everyone for attending this Ignite session today. We'll move into our next session. Thank you again.